Hi, my dear students. Welcome to GATE Wallah. This is Sathish Kumar, faculty of COA, Computer Organization Architecture ESE Mains practice session पर आपको मैं स्वागत कर रहा हूँ. So COA is there for both electrical and ECE both people. So mains में कैसा questions आ सकता है. Okay. So today's class we'll discuss some important questions. Let us start working on it. So let us start discussing some important questions on the COA. First of all, let me talk about what is the basic computer architecture and computer organization. So please make a note what is basic, very basic level I am starting. What is computer architecture and what is computer organization? So if you see the computer architecture what it talks about, computer architecture represents the blueprint of design of what type of functional units can be used. What type of functional units can be used? So what to do? What type of functional units can be used? What to do? Okay. Next, computer organization talks about it is the interconnectivity of various blocks of the computer to perform an action, that is how to do. So first please make a note, computer architecture is about what to do and computer organization is about how to do. So what is the computer architecture? Computer architecture represents the blueprint of design of what type of functional units to be used. So first of all, before starting to the subject, everybody must know the fundamentals, what is computer architecture and what is computer organization, how they are differing. Okay, chalo. Let us see this. Now see this question and try to answer. In this question, what they're asking? In this question, they're asking distinguish between high level language and low level language, machine cycle and instruction cycle, memory mapped and input output, IO mapped, okay, all those things. So now let us go for the programming languages. If you see the programming languages, high level language and low level language. So first of all, high level language is user friendly. Frankly speaking, it is user friendly, and low level language is machine friendly. Okay, and it is less memory efficient. It is more memory efficient. More memory efficient means why? Because it talks about processor architecture. Next, easy to understand, tough to understand. It is simple to debug, complex to debug. Yeah. So the key points try to understand. It is easy to understand, but it is tough to understand. It is simple to debug. It is complex to debug. It is portable. It is not portable. It can run on any platform. It is machine dependent. Compiler. So what a compiler will do, compiler is used for high level language to low level language. Assembler is used from assembly language program to low level language. So it is widely used for programming. It is embedded real time app. Okay. So that is one thing. Next one is mission cycle and instruction cycle. So what is mission cycle and instruction cycle? If you see the mission cycle is a part of the instruction cycle. Generally, what is the instruction cycle? Instruction cycle will fetch, decode and execute. Okay. The time required by the processor and is the time taken to fetch, decode and execute a instruction. The time required by processor to complete the operation for accessing memory IO, that is called mission cycle. Okay, one particular memory operation, it can be memory read, memory write, IO read, IO write. So generally these mission cycles will operate on memory unit and IO unit, whereas instruction cycles will operate on ALU control unit registers. Instruction cycle is group of mission cycles. One mission cycle is called number of T states. One instruction cycle is called M number of mission cycles. So please make a note of all these points. So one mission cycle is equal to number of T states and one instruction cycle is equal to M into N into T. Okay, make a note of it. mapped IO. So if you see the memory mapped IO and IO mapped IO, so this is the IO devices are accessed by the treating it as a memory location. Why? Because this memory mapped IO and IO mapped IO both are related to IO devices. So how you are treating the IO devices? How these IO devices are treated? Are they treated as memory devices? Are they treated as IO devices? Accordingly, it will work. Okay. So IO devices are accessed by treating it as memory location. IO devices are accessed by treating as IO device. The second one, IO mapped IO. It is 16-bit address is used here. It is 8-bit address is used here. And here for IO mapped IO, we are using only instructions like this. So we are using in and we are using out. So these are the devices. These are the instructions we are using. And here we are using move and LDA and STA. So these are the instructions we are using. Okay. So when memory mapped IO we are doing the hardware pin diagram, IO by M bar is equal to 0, and here IO by M bar is equal to 1. IO by M bar is equal to 1. Only register can communicate with IO devices here. So only we are using the register that can communicate. Only accumulator will communicate with in. Only accumulator. See, in and out instructions are on the accumulators. Only accumulators. Okay. So here 2 power 16 IO access. Here 2 power 8 IO access. Okay. So please make a note of these points. So this is 2 power 16 IO access and this is 2 power 8 IO access. Why? Because 16-bit address is the 8-bit address. Okay. So this is the thing. First one, high level language and low level language. Second one is machine cycle and instruction cycle. Third one is memory mapped and input output, and IO mapped. We have discussed that. Okay. So these are the differences. Next, another question was asked long back, that is on the memory differences, SRAM and DRAM. Okay. So what is random access memory? Questions here. What is random access memory? Explain the status random access memory and dynamic random access memory. That means he is asking the question on fundamental SRAM and DRAM. The question is all about SRAM and DRAM. So theoretical questions, so you should write categorically the points. Points easily you have to frame, proper points you have to frame. So RAM means random access memory, RAM means random access memory. So random access memory is a read and write memory, and it is a volatile memory. It is a volatile memory. When power is off, content is lost. When power is off, the content is lost. So most of all the content of RAM can be modified. So in RAM, the content is a read and write memory. We can read and we can write. So RAM is categorized into two parts, SRAM and DRAM. One, SRAM stands for static RAM. DRAM stands for dynamic RAM. SRAM stands for static RAM. DRAM stands for dynamic RAM. Okay. So now SRAM and dynamic RAM, if you see, so SRAM, if you check, it is a less access time. Static RAM takes a less access time and is faster than the DRAM. Okay. So whereas dynamic RAM requires a more access time. To access the data from the DRAM, you need more content, more time. Next, it is a costlier and it is a low cost. The expenses here more, here expenses are low. And it is stored in a 6 transistor based memory cell, and it is each bit for a capacitor. Consumes more power, it consumes less power. And your SRAM size is lesser than the DRAM. DRAM size is more than the SRAM. DRAM size is more than the SRAM. Okay. So please make a note of these points. So sometimes a question will be asked on programming also. See the programming question. Write a program in C language. So he's asking the question on C language. Write a program in C language to find whether the given number is even or odd, and if it is odd, find whether it is prime or not. So see here how to ask that question. So can you think of the code? See this question. Write a program in C language to find whether the given number is even or odd, and if it is odd, find whether it is prime or not. Okay, even or odd. So whether it is even or odd. So how to find out whether it is even or odd? So see here. First of all, even number. What is the concept of even number? When you divide with the 2, if the remainder is equal to 0, that is an even number. Okay. So void main int I comma n, int count is equal to 0. Printf, I am taking enter any number. First I am taking one number. So for printf and scanf, I think you know. So generally, to enter a number, we type a number, and to read a number, we need the functions. Printf is a output function, scanf is a input function, which will take the reading. Okay. So scanf %d ampersand n. If n divided by 2 is equal to 0, then printf even number. Else printf odd number. That's fine. Suppose if you take 1, 2, 3, 4, 5. So 1 divided by 2, remainder is not equal to 0. So like that, 2 by divided by 2, 2 is a even number. Now suppose how to find out whether that once that is odd number, then what is asking the question? See here, the question asked here is not only to write a program to find out the even. Write a program in C language to find whether the given number is even or odd, and if it is odd, find whether it is a prime or not. So if it is even, that's fine. Here it will be displayed. It will be displayed printf even number. Else it will be printf as odd number. That's fine. But question is, if it is an odd number, check it whether it is a prime number or not. So for example, what are the odd numbers? 3 is an odd number, 5 is an odd number, 7 is an odd number, 9 is an odd number. But 9 cannot be the prime number. For a prime number, what should be the prime number? Should be divided by its and its own number and 1. Suppose if you are taking the 5 should be divided by 5 itself, and 5 should be divided by 1. Okay. So now what I am writing, for I is equal to 1, I less than equal to, so whatever the number that you have taken, that n, whatever the n is there, so you go on dividing with this. So first I am taking 5, so I is equal to 1, 1 less than 5. Okay. So then divide the 5 with 1, the remainder will be 0. Okay. Then the count should be updated as plus plus. Next, if count is, and the count is now I plus plus means it's 2 less or equal to 5. So 5 divided by 2, the remainder is equal to not equal to 0. Count should not be updated. So number will be given to 3, 5 by 3. So 3 1 3, remainder is not equal to 0. Similarly 4. But for 5, we check for 5 by 5. For 5 by 5, the remainder is equal to 0. Again, the count will be updated to 2. So now how many times the count is updated? Only 2 times. So if count is equal to 2, printf it is a prime number, else printf it is a not a prime number. Okay, so please make a note of it. Topics here. So sometimes questions will be asked on theoretical terms. What are the requirements of memory organization? So see one more question in COA, computer organization architecture. Requirements of memory organization. What are the basic requirements of memory organization? If you see the memory requirement organization, please make a note of these are the points. So if you see the requirements of memory organization, the requirements are memory distribution, deallocating memory, memory fragmentation, memory security. Okay, so these are the basic requirements of memory organization. How the memory should be organized. So that is given from this lab. So memory should be how the memory is distributed, how the memory has to be secured, how the memory has to be deallocated, how the memory sharing. Okay, memory fragmentation, memory mapping, and virtual memory. Okay, these are the requirements of memory organization. Now let us see that how they will work. Similarly, how the IO organization. See, what are the different types of IO organization? So in COA, basically it is all about the how the functionality, how the interconnectivity is taking place between the devices, how the interconnectivity is taking between the devices. IO organization. IO interface is a hardware component or system that interfaces and manages the data transfer between CPU, memory, and IO. So that means if you see this is a CPU, this is a memory, these are input output devices. So these are interface, this is a keyboard, these are different interfaces, keyboard, printer, monitor, and this is our bus. So how these devices are connected, how these particular devices are connected. IO interface is a hardware component or system that interfaces and manages the data transfer between CPU, memory, and IO external. Okay, external devices. So IO organization deals with how the different IO devices are getting connected. How the different IO devices are getting connected. IO interface is a hardware component or a system. Okay, remember that. So what are the different functions of this IO interface? Actually, we see this particular IO interface is going to do certain functionalities. So when you're connecting the keyboard directly to the CPU, you cannot connect now. So you need some interface, some user interface. The printer is connected to this, monitor is connected to this. How they are connected? So if you see functions of IO interface, if you check now, seriously, the speed synchronization. First of all, the speed has to be synchronized. Whereas CPU is a very faster device, IO devices are very slower devices. So CPU is faster, and IO devices are slower. CPU device faster, IO devices are slower. So this is speed synchronization. Second is processor communication. Command sends from the processor. Next, signal control, timing signals between the IO interface and the CPU. Next, data buffering, temporary storage of data coming from the IO device CPU. Data conversions. See how the data has to be converted. Why? Because you are sending 1, 2, 3, 4, but inside the system it is going to take an ASCII code. Am I right? Inside the system it is going to take an as ASCII code. This is error detection. This is status reporting. Okay, so these are the functions of IO interface. Please make a note of these points. Speed synchronization, CPU is faster and IO devices are slower. Processor communication, command sent from the processor. Signal control, because when you are dealing with the fast device and the slow devices, okay, so we need a speed control because signal control also required. Why? Because this fastest fellow will be sending the data Whether the data is reached to the IO device or we don't know, without knowing that another data he will be sending. So, but the IO device is very slow. So, IO device has to respond him. I have not received your data, so you have to wait. So, there should be some interface. So, what this interface will do, this interface will introduce some wait states. The wait states are coming from the processor, wait states are given to it. Okay. And similarly, when you are sending the data from this to this, serial to parallel to serial also required. If you are moving from system to outside, within the system the data is parallel. Within the system the data is parallel, but out of the system the data is going to be serial. Okay. And similarly, the data is coming from outside to the computer. The data is coming outside to the computer. Then that is, one second. These are the things. Yes. Karthik Yadav, are you there? Yeah. Have you noted IO organization features? Chalo. Now let us go for what are the different types of IO organization. Different types of IO organization in computer systems. The different types of IO organizations are programmed IO, direct memory access based IO, interrupt driven IO. Programmed IO, direct memory access IO, interrupt driven IO. In programmed IO, in microprocessor based system, it is supported by a peripheral 8255. Direct memory access it is supported by 8257 or 37, and it is supported by 8259. So this is PPI. PPI stands for Parallel Peripheral Interface. 825737 it is by DMA controller, and 8259 is called as Priority Interrupt Controller. Priority Interrupt Controller, PIC, Priority Interrupt Controller. Okay, na? Okay. So please make a note of these points. So how they will work, we'll see step by step. And whenever you are dealing with IO devices, the things are like this. The IO devices can be addressed as two techniques, as a memory mapped IO or IO mapped IO. In memory mapped IO, it is treated as memory just before I told you. In IO mapped IO, it is treated as IO device. And here we are using in and out instructions only. And here the syntax is in AL comma ATH, where this ATH is a port address, my dear. This ATH is the port address. Okay. Any instructions reference with memory, that is treated as memory. LDA 2000, STA 3000. Okay. So here the port address is 8-bit. Here the port address is 16-bit. Okay. So as it is 8-bit, we get total ports successful 2 power 8 ports. Here it is 2 power 16. See, the number of ports have been increased here. So number of ports have been increased here. This is 2 power 16. So address bus is 16-bit. Okay. So please make a note of these points. All of you are there understanding? COA समझ नहीं आ रहा है आपको? Computer organization architecture is not clear. Questions. Actually, we are discussing the mains questions, my dear. We are discussing the mains question. Okay. Discussing the mains questions. In mains questions, what are the differences they can ask? COA. Chalo, next. Now in IO organization, the first one is the PPI, 8255 PPI. 8255 PPI, which is called as Programmable Peripheral Interface. What we call it as Programmable Peripheral Interface. It's also called as Parallel Peripheral Interface. How it works? It serves as an interface between the CPU and IO devices to communicate with the programmed IO byports. Okay. So generally 8255 is a chip, hardware chip. So this hardware chip is used to communicate with different IO devices. So the devices present are port A, this is port B, and this is port C. So 8255 is having 3 ports. Port A is port A0 to port A7. This is port B0 to port B7. This is port C0 to port C7. So these are 8 pins here. So here 8 pins here. So these are 8 pins. So total 24 pins. समझ में आपको? And these 8 pins can be categorized into port A, port B, port C, and the port C is generally divided into low and higher like this. So this is PC0 to PC3, it is the lower, and PC4 to PC7 is the higher. Please note down. Surya Yadav, are you there? Note. So port C lower, port C higher. So now let us go for this. As I told you, this IO organization contains two groups, group A, group B. In group A, we are having port A. Port A is port A0 to port A7. Group A is combination of port A and port C upper. Group A is a combination of port A and port C upper. Port C upper is PC4 to PC. As I told you now, port C is divided into two parts, PC0 to PC3, PC4 to PC7. So this is a port C upper, this is a port C lower, and port C lower comes here. Okay. So in group B, we are having port B plus port C lower. So port B is PB0 to PB7, port C lower is PC0 to PC3. So these two parts, PB0 to PB7, PC0 to PC3. Done. So this is a port A, this is a port C upper, this is a port B, port C lower. Make a note of these points. Group A, group B. Two groups. Any doubts you can ask me, my dear. Karthik. Okay. Chalo. Now the working modes of the 8255. 8255 works in two modes. One is the bit set reset mode, other one is the IO mode. Okay. So 8255 chip works in two modes. One is the BSR mode. This bit set reset mode can be called as BSR mode. Okay, this is IO mode. So the modes are mode 0, mode 1, mode 2. So mode 0 can be worked in three: port A, port B and port C. Three ports can work there: port A, port B, port C. Whereas mode 1, port A, port B are used, with port C used for handshaking and control. Mode 2, port A only. Port A only, why? Because it is a bidirectional. So please make a note of all these points. Clearly note down. Karthik Yadav, you are preparing for IES mains. So IES mains के लिए ये questions very very important है. Okay, make a note of these points. Done. Chalo. So now whether the 8255 is working the bit set reset mode or IO mode, that is decided by one register. That register is called control register. This is control register. So based upon the control register value, the mode of operation is decided. What type of mode of operation is working? So for example, if it is a bit set reset mode, it is a bit set reset mode. See here. So it is having total 8 bits, D0 to D7. So here comes MSB. MSB is always 0 here. MSB is always 0 here. If MSB is always 0 na, it is a bit set reset mode. Next. So next, if port C3 is used na, so this is 0. So this is a port C number. This is a port C number. D1, D2, D3 are port C number. Suppose if port C not, this is 0, 0, 0. Port C1, 0, 0, 1. Like this. This is these are the things. Okay. See here, so if port C3 is used as input, for input this will be 1, for output this will be 0. For input this will be 1, for output will be 0. Now when I am saying port C3 na, so this is 0, 1, 1. So these are the don't cares. These are what? Don't cares. So either they can be zeros or ones. So now what happens? This is 0, this is don't care, this is don't care, this is don't care. This is 0, 1, 1, 0, 1, 1 and 1. Okay. So this is the number. So we can take, if all zeros, then the number will become as what? 0, 7. The control register value will be 0, 7. So please make a note of these points. Control register value 0, 7. Very interesting, na? Similarly, first you note down the bit set reset mode, then the IO mode, input output mode. This is also called as IO mode. So for IO mode, the control register is different. For IO mode, the control register is different, and Bit set reset mode also it is different. So this is the IO mode. IO mode. So please note down. Bit set reset mode. So port 7 ki this is 1 1. This will be 1. D1 D2 D3 होना चाहिए इधर. This is D1 D2. Okay. Next one is IO mode. Please make a note of this point. IO mode. IO mode. In IO mode, what is going to happen? In IO mode, this is D0, D1, D2, D3, D4, D5, D6, D7. In IO mode, the MSB will be always 1. Okay. Now these 2 bits for the mode selection. So these 2 bits for the mode selection. Mode selection. So 0, 0 means mode 0. So these 2 bits, D5 and D6. And this is 0, 1 means mode 1, 1, 0 means mode 2. Okay. Next, this is D4 bit. If you check, this is either input or output mode. So if you have a port A, this is 1 means input, 0 means output. Okay. Next, this is IO function. This is a port C lower. This particular is for port C lower. This is for port B IO function, whether port B is equal to 0 or 1. And these 2 bits for the mode 0, mode 1. Okay, like that you have to understand. Suppose if all the ports are output ports, then the controller should be all 80s like this: 1, 1, 000, 000. So this is 80. So this is what we can write. We can write this as 1, 000, 80. So this is going to be happen as 80H. Okay. Once again, I will explain you. MSB will always 1. These 2 bits for the port B, these 2 bits for the mode selection of port A. Mode selection of port A is 0, 0 means mode 0, 0 means mode 0, 0, 1 means mode 1, 1, 0 means mode 2. Port A can work in mode 0, mode 1, mode 2. Next, this one, D4th bit, this is a port A functionality. Port A functionality means input or output. If it is 1 means input, if 0 means output. Next, this one is port C upper. So this port C upper. Port C upper, either input or output means either 0 or 1. Next, this one is for the mode selection. This one is for the mode selection, my dear. So this is for the mode selection. Port B mode selection. Mode 0, 0, mode 1, 1. So this for the port C lower. Okay. This one down. This is for the mode selection. This is how it will function. How it will function. Okay. So based on this, we can write what is mode 0, what is mode 1, what is mode 2. We can write. So this is a mode 0 operation, mode 1 operation, and mode 2 operation. See here, what is mode 0 operation? Mode 0 operation means all the 3 ports, port A, port B, port C, can be function either as input or output. So please note, mode 0 means all the ports can be functioning as input or output. Mode 1 means port A and port B can work as simple IO, whereas port C generates the handshake signals before the actual data transfer. Port A, port B will work in mode 1, whereas this port C generates handshake signals before the actual data transfer. So now if this is a CPU and this is a printer, so this is a data actually, but before data we will send after sending the strobe signal, then acknowledge signal, then the busy signal. So these are the handshake signals. Strobe, acknowledge, busy, these are the handshake signals. So these handshake signals are generated by the port C. Okay. All handshake signals generated by port C. Port A, port B is involved in data transfer. Port C lower and port C upper will be involved in handshake. Okay. Mode 1 is for port A, port B can work. Port C generates handshake signals. Whereas the another one is there, mode 2. Mode 2 is a bidirectional data bus mode. Bidirectional data bus mode. In this mode, only port A works. When port A is working in mode 2, now port B works either in mode 1 or mode 0. So port C generates a handshake signal. So try to understand. Mode 2 is dedicatedly reserved for the port A. Okay. So please have a note of this, and based on this, try to understand how the IO organization works. Okay. In the upcoming classes, I will discuss some other content. In mains, we can get expect this type of questions. Make a note of it. So COA is such a subject. Miss mat karna. Basic questions are asked. Sometimes programming related questions are also asked. Miss mat karna questions ko. Chalo. Any doubts you can ask me. Enough for today.